Hi, in this video, we're going to see how we can use functions and parameters in microbit to make our programs more versatile. Let's get started. A function is a way to create a new word that the computer will understand. We list a set of commands and give the function a name, and every time we call that name in our program, the computer will run the commands we have set. Let's take a look at this simplistic program that draws an image of a heart with LEDs on our screen. Though each command is very basic, we still need to light 16 individual LEDs in order to create this image. In order to shorten our code, there is a command built into our MakeCode editor that will take the icon name, in this case, heart, and display it on the screen using only one command. This is an example of a function that shortens our code and makes it more easily reusable. Let's take a look at how we can define our own functions in the MakeCode editor. To define a function, we use this syntax. Let's explore it. We start with the keyword function in all lowercase letters. Next, we write the name of the function, adhering to the same naming rules we learned for variables. We then write any parameters needed inside parentheses. If we don't need any parameters, the parentheses can remain empty. Indented inside a set of curly braces, we write all of the commands we want to be performed when we call this function. Then, to call the function anywhere in our code, we simply write the function name followed by a set of parentheses. Any arguments needed for the parameters can be included here as well. Let's take a look at an example. In this program, we are defining a function called moveLED. No parameters are being used, so the parentheses are empty. There are 3 commands inside this function. There are 2 places we are calling the function inside our program, once inside each if statement. So when this program runs, each time button A is pressed, the lit LED moves to the left, and when button B is pressed, it moves to the right using the moveLED function. If we want to include parameters in our functions, we need to write them in a specific way that is a bit different than you may have previously seen. We have to first write the name of our parameter using our naming rules. We then write a colon and a type. The type is the kind of value the parameter will hold. In this class, we'll stick to using these 2 types. Number will hold a numerical value, and string will hold a text value. For example, if we wanted to use a parameter inside our moveLED function, we write the parameter name, in this case xcoord, followed by the type, in this case number. Let's look at an example. If we wanted to change our previous program to make the LED less bright as it moves away from the center, we can make these alterations and use parameters. When a button is pressed, we are first calling the moveLED function. You'll see that this function does not take any parameters, but uses the value of the x coordinate to call the setLED brightness function using different values as arguments. The setLED brightness function takes one parameter that is used inside the function to control the brightness of the LED being lit. This function is being called with different parameter values from the moveLED function. We can call functions inside other functions. So when this program runs, the output is an LED that is moving based on button clicks and changing brightness depending on location. Let's take a look at an example that combines all the control structures we have learned. In this program, we light the top or bottom row of LEDs when button A or B is pressed. We are already using if statements in our code, but is there more we can do? The program functions perfectly fine, but we can make it shorter, more versatile, and more readable if we use some control structures. First, we could use for loops here to light LEDs from 0, 0 to 4, 0, which will definitely shorten our code. Now, the value of I in each for loop is being used to control the x coordinate of the LED being lit. Great work! We could now place these commands inside functions to make our program more readable. This looks great, and it is now much easier to understand the tasks the program is completing. But these functions are very similar, with just the y coordinates of the LEDs being different. We could use just one function that includes a parameter here to make our program more versatile. Now we have a program that is clear, concise, and effective. Using control structures together inside our programs is what makes computer programming so powerful. During your next exploration, you'll be using a new external sensor. An ultrasonic rangefinder is a sensor that measures distance using sound waves. There are different types of ultrasonic rangefinders, but in this course, we'll be using the HC SR04. There are 4 connection pins on the sensor that must be plugged correctly into your circuit. Looking at the front of the sensor, the VCC pin is on the left. This pin will be connected directly to the red wire of your battery. Note that similar to when we used a battery pack with the servo motor, we connect nothing to the 3-volt pin on our microbit, and instead use the power from the battery pack. To the right of that pin is the trig pin, and to the right of that is the echo pin, which are both connected to pins on your microbit, either 0, 1, or 2. The final pin on the far right of the sensor is labeled ground and will be connected along with the black wire from the battery pack to the ground pin on the microbit. In this lesson, we learned how to use functions with and without parameters inside our programs. Now it's your turn to give it a try.